Hello, hello, hello. Today we are live, I guess, on our stream part 5. And what we'll be doing is that we'll be going through the Rust docs, Rust by example. And here is our Rust by example. Uh, Let me see if it is live and everything is right, all right. Hello, hello. I don't hear myself, so is there any problem? I think so. I don't hear myself, so is there any problem? I think so. I don't hear myself, so is there any problem? I think so. I don't hear myself, so is there any problem? So today we'll be going through the flow control, which is eighth. In this we'll learn if, else, loop, while, for, and range, match, if let, and let else, and while let. Oh, let's see. What's there? Hello. Yes. So I'm audible. Everything is clear. So let's go. So, in flow control, an integral part of programming language are ways to modify control flow, which is if, else, for, and others. So, let's talk about them in Rust. So, let's start from if, else. Branching with if, else is similar to other languages like Python and C. Unlike many of others, the Boolean condition doesn't need to be surrounded by parentheses, and each condition is followed by a block. These are blocks, right? So these blocks, the curly braces. If else conditional are expressions, and all branches must return the same type. So here we see this program. It has a main function in which we have a variable n, which is immutable. It is 5. And we say if n is less than 0, then print that it is negative, n is negative. If it is greater than 0, we'll print n is positive. The value of n, like 5 is positive, 5 is negative. And else we print that the 5 is or the n is 0. All right. So what shall we see? We should see something like this. 5 is positive. Let's go. And then we have a let big N. So what does that mean? So there is a big N and we have not assigned it a value. So let's see what are we doing. So if N is less than 10 and N is greater than minus 10, which means that print ln that and is a small number and increases tenfold. This expression returns an i32, so this is returning i32 to big N. All right. Else, what we'll be doing is print ln, and then inside that we'll say that and is a big number, half the number. Well, quite interesting, but what's happening? Then we'll say this expression must return I32 as well, so n by 2. So to do, try suppressing this expression with a semicolon, and don't forget to uh, forget to put a semicolon here too. Well, there's obviously already a semicolon, and then we are doing what? We are printing the n and big N. So we are getting n from here, which is this. Why I'm printing this? Because I guess I can't guess. 5 is positive We are saying print. All right. If we say something like print ln, then we would get a new line and we'll be able to distinctly see that we are obviously printing it. It's not a scam. Print ln. What does ln means? Ln is nothing. It L looks like the backslash and the n looks like a new line. So backslash n. That what it signifies. So if we see print ln, it means print back with backslash n. So let's run it now. See what happens. You should see that now 5 is positive. Yeah, we see that 5 is positive, and we are seeing this statement alongside with it. That's what we wanted to do. 5 is positive and is a small number, increases tenfold, and then we increase the 5 by tenfold by multiplying it by 10. If it is like n is less than 10 and greater than minus 10, then we do this, we make it tenfold. Else what we do is just halve it by 2. So we halve the n. If it is, let's say, 12, we'll halve it and make it 6. And we'll say that n is a big number because this was n. So we'll say, let's say this becomes a 12. Let's do it. Then what we'll say is 12 is a positive number and is a big number, and half the value is 6. All right. So this is a nice if else statement, and we did not needed to create this ln. I just created this so that we can distinctly see this statement and that statement simultaneously. So we are able to see that without any confusion. And this is also print ln. So we are seeing this n and the big N. So big N is assigned the value of whatever the condition is getting satisfied, and then values getting assigned to big N, and we are printing that big N over here. We can't just use big N before it even assigns the value. So we can't use it in else block or in this block anywhere else. So it's telling me to try suppressing the expression with a semicolon. Let's do it, and we'll see something like error, because else statement. Now we'll see sometimes. So what is it? Help, consider removing the semicolon, expected integer not found. So yeah, it is expecting integer because it is trying to assign the big N, and now it can't find any. So if and else have incompatible types, because if returns this and else returns this. What if they both don't return anything? Ah, then it says required by formatting parameter that big N should also be, cannot be formatted with default formatter because it has not been implemented the type of this. So how about we try the debug? Oh, we can't print the question mark. So how about we just copy it? Oh no. Yeah. So we see that if we are not returning anything, it is getting a unit type. That's what we expected. All right. Because if you return nothing, by default, Rust returns this unit type to like every block or every whatever this is. What is this block? Yeah, every block or every function. All right. So this big N is now assigned the value of this unit type because we did not return anything and we blocked both of them. If we just not block one of them, and the return type will be something else. So it says again that expected because of this. So if this was also a statement, then we would get just avoid type, just a unit type. But since this is int 32, integer 32, and it is not, so it should as well be integer 32. So yeah. How about we remove everything, and we also remove this semicolon. Ah. So hell, add a semicolon here. Why? because print ln and whatever unexpected token, because of this statement we have to add this semicolon over here. Could not compile. Expected this but found print ln. All right. So we want to, stop this conditional from taking any more stuff and going on. Yeah. So this is the normal working. Let's move on. We know if else. It's exactly like C, because in Python, I guess it is elif. All right. They shorthanded it somehow and they said it makes sense. So yes, it makes sense. But over here, this is a if and else statement. This is one, and inside that else statement, we are again nesting this if and else statement. So it is nothing sort of magical, but it looks magical. So yeah, in else, even if here we can say again if, and it can go on. So I guess we are clear with if else. So let's move on, because there are multiple types like loop. Uh, if I remember correctly, there was also a forever loop in C. What was it called? Uh, I guess it was also called forever loop or something like that. But over here also we have a loop which goes on. It's not like a while loop, it just goes on. So Rust provides a loop keyword to indicate infinite loop. Yeah. And then break statement can be used to exit a loop at any time. Whereas the continue statement can be used to skip the rest of the iteration and start a new one. So we have to keep in mind that there is a break statement. We know that a little bit. And there is a continue statement. We also know that a little bit. And continue statement can be used to skip the rest of the iteration and start a new one. What does that mean? We learn. So let's see. There's a main function. Inside that we have a mutable count, which is first of all 0 and of type u32, because it will be positive and it is an integer. And then we are saying print that let's count until infinity. Then we are making an infinite loop. Inside that we have a count iteration, or shall we say, we are adding 1 to the count. So if count is 0, it will become 1. If it is 1, it will become 2. And then what we are doing is we are satisfying a condition. So if count becomes 3, which is equal to 3, it is not assigning, it is equating. So if count becomes 3, then we'll print 3. And what else? Skip the rest of the iteration like this. We'll skip these iterations because they are also inside loop. But in the case of 3, we already have a specific condition in mind. So we'll only run this and we'll then continue, which means we won't be printing this and loop will return from here. So it says skip the rest of the iteration, that is this, and loop will just return from here. Else, if it is not 3 and any other case, so what we will be doing is we'll just print the count and whatever the number is, and we say if count is equal to 5, then we are printing that okay, that's enough, and we are breaking this loop. So if this condition satisfy, we print okay, that's enough, and we break this loop. If this condition satisfy, which is 3, we continue without printing this line, and we don't even go to this, but it will not satisfy even if it was going over there. But we return only from here. All right, we return from continue. But if it's, let's say, 4, we print the 4. If it's 5, we print the 5, and then we say if count is equal to 5, and then we say okay, that's enough, and we break that. Let's run it. Yeah. So we see 1, 2, 3, and instead of saying 3, because we are not printing the value, we are just printing the 3 over here. All right, so we are saying 3 and not the value, because it continues from here, which means it skips the rest of the iteration. So this doesn't even come near printing the 3. And then we say 4, which goes over there, and then we say 5, which which just goes over there, and then sees that there's a conditional statement, and it sees that there is a print statement inside that. Okay, that's enough, and break this loop. So I think good enough. We know loop. It has two keywords that we should keep in mind. That is continue. Continue will just uh, not go through the rest of the iteration like this, and break will just break the loop. All right. There is no condition to satisfy outside of the loop, like while I is less than 2 or something like that. All right, we just have a break statement. So if you want to do something like I is less than 2, then we can create a if statement inside the loop, and we can say I is less than 2, and if it's satisfied, it breaks. That's how we can just use this loop. Let me see it. All right. Now there is nesting and labels. So what does that mean? So it is possible to break and continue outer loop when dealing with nested loop. In these cases, the loop must be annotated with some label, like some label, and the label must be passed to break or continue the statement. All right, let's see the code, and I'll be talking about that in a minute. All right, so there is nesting and labels. So it is possible to break or continue outer loops when dealing with nested loops. In these cases, the loop must be annotated with some label, and the label must be passed to break or continue the statement. So let's see. Now there is a loop which has a, I guess, label outer. Then there is a loop which has a label of inner, and then we are breaking the outer loop. So to create a label, I guess we have to, use a single, quotation, or these ones. No, we have to use the single, quote, but it is not quoting it, so it becomes apostrophe. So we have to use a single apostrophe before the word starts. So we are saying apostrophe then inner, which is the label for the loop, this loop. And if we say break inner, then it will break that. And if we say break outer, then it breaks the outer. And then inner loops doesn't run because we break the outer loop. Or does it run? So let's see. Exited the outer loop. So we see that we entered the outer loop, then we entered the inner loop, and then we break the outer, and then we go over here. No, not over here, directly over here. Because the outer loop is broken, so we directly get out of the loop. We jump out of the loop. And we go the next line after these loops, which is these. So exited the outer loop, and that's what we see. What if we don't break outer loop? I don't want to crash my computer, but for the sake of it, let's just see it. Playground communication cannot read properly. Undefined reading trim. What is that? I guess it is saying something that we are doing something stupid. Don't do it. Let's see if we get any errors or warning over here. Rust C. No. Vim. Alright. We're creating it first. One.rs inside that. Yeah. So now we go Rust C and then one.rs. We see everything is clear, so we'll run one.rs. Then we do something right? And we go to compile it. Oh, it compiled. Damn. All right. I have one hand on Control C, so if anything goes wrong, I am ready. Oh. So it first went into the outer loop, and directly after that it went inside the inner loop. And see, I can't even go to the topmost part of it. Damn it. And after that, we did not give it a second chance to just get out of this inner loop, so it just went on. So let's create something more interesting, like this would break only if the inner loop. This would only break the inner loop, but would not break the outer loop. So let's only break the inner loop and not break the outer loop. All right. Let's see. We compile it. We run it. I have my one hand on Control C, so let's go on. Done. So it says this point will never be reached, but it has reached because we just break the inner loop. It says enter the outer loop, then enter the inner loop, and then this point will never be reached. Enter the outer loop, and goes on. And since we have not exited the loop properly, so we don't see the last statement, which is exited the outer loop. All right. So we create some statements like, oh, there's no n now. So let's create an n, which will go through just types loops. So let mutable count, no, mutable n, let's say n, uh, is equals to how much? Let's say 5. And over here, we say that like this. We say, not over here, over here. We'd love to say if n is equal to 5, then just break this loop. Right? But for n to, you know, now this will run unconditionally because n is, 5, but we are not breaking from the outer. So over here, uh, we have to create another statement which will look like this. If n plus 5, not 5, let's say 3 is equal to 5 plus 3 is 8. So we are creating some direct hard-coded numbers, which is not good, but we are just doing it for the sake of doing it. And we'll create it. So I think we shouldn't get any problem. We should see something like this whole program just, ah, we are not mutating, and so it says just do that, but it is a warning, so we can run a compiled version, which is this, and we'll see how many statements. So 5 from both of them, and then 3 from the outer loop, because we are then exiting the outer loop. Then after that, the 2 statement at the last. Let's see. It never breaks the outer loop. What is it? N plus 3 is not 8. Then what is it? Which condition is not getting satisfied right now? I don't think. So instead of making it so complex, let's just directly take this, print it over here. Let's see. Remove one not plus C. ls. Yeah, we are getting the newer compiled version, but still nothing happens. I think now we are stuck in a loop. It says allow unreachable code, unused labels. Mhm. I want to see something interesting, but we have a count. We are creating a count. We are counting it to three, first of all. So let's also create a count from, you know, zero. Let's create it from zero. And then where do we say this? In the outer loop, let's say this that n plus, we'll say n plus equals to 1, which is like appending 0 to 1. And at some point, it will come to, becoming equal to 5. It should work, but why is it? Why? I don't know. Now there is statement problem because we did not add um, semicolon. Now we did. How about now? Yeah, there's no problem. I think this should work now, but it is not because we are now stuck in a loop and we are maybe getting out of this. So instead of appending this over here, let's do this instead in a loop. Give it a tab. It works. It's solid to me. Try compiling it. It compiles. Try running it. Runs, but it's still in a loop. I don't know why. But I am guessing why. Because first of all, what it does is goes over outer loop, it does the inner loop, and then prints this, and just goes on printing this because we are not getting out of this loop. Because I think this is mentioned over here. Let's mention it inside. Let's append it. Give it a tab. Let's move on. How about now? I don't think this will also work because we are doing something fundamentally mistake over the fundamental mistake. So what it says, it has changed. This point will never be reached. The outer loop, then the inner loop, inner loop, inner loop, inner loop. We have you know, three, four, five inner loops. Then we are printing one outer loop. Then we have five inner loops. Then we are printing one outer loop. Why is that? We are printing this five times. How about we, instead of just saying break, we say break inner? How about that? Will that seem like what? Inner. Now we are mentioning by its name. Now what? Compile it. It compiles. Run it. Should. Nah, it doesn't. What is it? We still have five inner loops, one outer loop. Whom should we ask this from? I think I'll just use a chatbot model to ask what's happening right now. So let's add this one as let's copy it. Let's go to some. Oh, there was a chatbot model. Leo AI. Let's do that. Uh, what's uh, this paste value? Let's go on. So the issue is that break outer is unreachable code. It comes after break inner, so it will never be executed. But oh, oh, since break inner exists in the inner loop, first the break outer on the next line is a dead code. So how about we just reciprocate it? All right. So instead of saying break inner and just breaking for the from the inner loop, how about we say, that's why. So inner loop just break, but instead outer loop started running, and that's why the inner loop also started running because of the outer loop. That's why we were saying this, and then five times this. After five times, it will just breaking the inner loop. Yeah, so that was the fundamental. Oh, sorry. Now we know print over here. We'll first break from the outer loop and then we'll break from the inner loop. I think this should work, but let's see. Ah, so we are entering the outer loop, then we are running the inner loop for five times, and then we exited the outer loop. And the core that should never be reached, the this point will never be reached, was never reached. Thanks to that. How about we make something now more interesting? So yeah. How about instead of doing it in inner loop, we do this in outer loop, like over here. We say print, then we go out of here, and we there is break inner undeclared label. So inner only works inside the inner loop. So we just have to say instead of break inner, just have to say break outer. Will that break from the inner loop? I don't think this will work because the inner loop will keep on just see, that was a problem. So what we want to do with this inner loop is first of all append one to the n, and then what? Then just break it. Let's copy this. Let's paste it over here and uncomment this. First of all, append the one, then break the inner loop, and it should go on until and unless the n becomes 5 and we break from the outer loop. That's what we want to achieve right now. So let's go on. But it has never been achieved. Why? What it says is this point will never be reached, but it did reach. We entered the outer loop, we entered the inner loop. This point never be reached. So this is our loop now. What's happening? Let's see. So I guess we entered the outer loop, we entered the inner loop, and then we see this. And instead of breaking out of the outer loop, we just keep on. But this statement breaks the inner loop. And I think this statement is failing to. Is it because of this? Let's print it over here. Will this work now? It worked. So we entered the outer loop, then entered the inner loop. Then this point will never be reached, but we are then seeing the conditional over there. So it did reach. Then we are outer loop, inner looping, and then again we are doing this for I guess five times. Then since we are exiting the outer loop, see this message also. So this works. This works. So let's remove this, whatever this one and this is. Let's clear it. So we played enough. We don't need your suggestion, sir. Thanks for that. I needed a clarification. So I think it is now pretty clear what's happening. we have, oh, not over here, over here. Now this nesting and label is pretty clear. This is label of the outer loop. It will work only inside some block, not over here, over there. Let's say if there is a break inner, then it will work only in this inner loop. If we say this outside of this inner loop, I think we already did escape the inner loop. So there is no inner loop after that. That's why it never works. If we over here say something like break inner, if we say something like that, we are doing something stupid. And it the rest will not throw us an error. I know. I thought it was safe, but it is not. Ah, this is a human stupid mistake. This is not even running right now. Or is it? It is running and it says compiled. Ah, undeclared label inner. So we are getting undeclared label. Did we get over here? I think we must have, but since there is so much of loop running, I don't think we'll see that. All right. So let's move on. It is pretty clear to us. Let's reinstate it. Let's move on. STK labels is done. Let's go to the returning from loops. Is it the next topic now? Yeah, so inside loop, we are seeing these two. So nesting and label was the first one. Now this is returning from the loop. So one of the uses of loop is to retry an operation until it succeeds. So if the operation returns a value, though you might need to pass it to the rest of the code and put it after the break, and it will return by the loop expression, something like this. Let's say there is a mutable counter which is right now 0. We can change its type to U32 if we want to, but let's do it. Use this so that it becomes more clear. And then what we are doing is we are saying that let result is equals to loop. So on result, we are looping and making the counter +1. If the counter becomes equal to 10, then break counter with the value of this. And if by any chance we don't break this counter, we don't break this loop for the result with any sort of value, then it will give us this exclamation, which I think is called something like none, null, something like that. All right. So let's see this. No output. It means this is doing its work. Let's make it our 30. Now we will see the assert equality sending some message that left assertion failed the right assertion equal to. So result is now not equal to 30. So we get the point. But now what I want to do is just break this without even sending any sort of value to it. So we'll break this loop, we'll assign that value to the result. And now what it says, expected this and found 20. So if we say that we expect this unit type, will it satisfy? Ah, it did. So what was that? Where did I see something like that? How about I say that counter is now -10 instead of 10. -10. What will happen? This will keep on running. For how long? Playground communication timed out. So yeah, it was a forever loop. And playground stopped that for us. Nice. So we are getting the result, the value of counter multiplied by 2. So if we want to print the result, will we be able to print ln? Then inside these, no, first of all macro, and then inside these we are saying uh, printing result not golden. Inside this, we need a value. Then we say this is result. And a semicolon is important. So let's give that. It is 20. Let's make it 30. We'll get an error from assert equality, but doesn't matter because we are printing a value. So will it print or will it just not? Ah, so we should keep this below our printing statement. Now let's go. Did it print? No, it didn't. So I guess we'll just have to comment it out. Let's go. We are getting a printing result of 30. All right. We are seeing printing result, but we were not focusing enough. Why? Because first of all, it goes to this print statement and prints whatever it wants to. Then it goes to this assert equality or whatever this is. And then we see that assert left is equals to right failed because left is 30, right is 20. Yeah. And the loop, whatever looping over here is getting a value of the result. What if we don't use the semicolon? All right, let's add that semicolon over there. But instead of returning this breaks value like this, how about now? This fail. Let's make it normal and do it. Printing result is all right. How about we just break the loop instead of doing anything with no semicolon? So we are returning the value of break. See, first of all, just comment it out and let's see only errors. We'll get errors. So what is it required by formatting? So it can't format this. And can you? The assert equality also shows no. The left is this, right is this. Expected this and found the integer. So it expected something like void type. I'll have to copy this question mark over here because I can't type question mark. Because as soon as I do, hmm, only this is the now. So let's comment it out. Let's try printing it. Yeah, we printed the result, which is printing result, which is void type. Sorry, unit type. Over here, we are not. So what if we return it without any value? We still get the void type, I guess, or unit type, not void type. Yeah. Now what? Now what? Whatever its type is, it just gets assigned to the result, which is let result, because we are not assigning any value to it explicitly. It has to go through this loop and then get the value from this break. I think we'll move on because we are returning from loop, which is returning a value from this loop. So one of the uses of loop is to retry an operation until it succeeds. So if operation returns a value, so you might need to pass it to the rest of the code, put it after break, and it will be returned by the loop expression. Good. Now we say while, which is again a loop. Now, then we have a for range and then match, then if else, what is inside match. So there are, oh, now match is something nested. over here. Match is going to be well long match. So let's see the while keyword. 2 minutes. Hmm. So we have while loop. The while keyword can be used to run a loop while a condition is true. So let's write the infamous fizz buzz. What is this? So let's see what is this fizz buzz first of all. So fizz buzz is a group word game for children to teach them about division. All right. So play fizz buzz fizz. Oh my god. So players take turn to count incrementally, replacing any number divisible by 3 with the word fizz, and any number divisible by 5 by number buzz, and any number divisible by both 3 and 5, we say fizz buzz. Alright, so let's go over there. We are creating a mutable n. Where is our cursor? So we are creating a mutable n with a value 1, and we go over the loop till 100. So loop while n is less than 101, which is 100, and we say if n is divisible by 15, that's what it says, no? N dividing 15 and remainder is 0. So it means it is divisible by 15. We said fizz buzz. Was it 15 or was it 5 and 3? Yeah, over here it says both 3 and 5, which means 15. All right. Yeah, because 3, 5 is sort of 15 is the LCM. So yeah, that's why we are doing it. So if anything is divisible by 3 and 5 simultaneously, it should come in the table of 15 only. So I am getting the logic over here, but all right. We could also do that explicitly, like n divisible by 3 and n divisible by 5. If both are equal to 0, then we'll do this, but we are creating just the LCM and doing the same thing, which is fizz buzz. And then we are creating else if that n is only divisible by 3, we are creating fizz. If n is only divisible by 5, we are creating buzz. Else we do nothing, which is this. We just give it the n, value of n, like 2 or 4 or something like that, which is not divisible by the 3 and 15. And we are incrementing it at the last. That's what we do in the while loop, incrementing the counter. Now let's see. It will be a long result. Yeah. So you see fizz buzz. Oh, 99 is divisible by 3. Buzz means 105. All right. Fizz buzz, which is 90 by both. So it is an interesting result to see. And we know how to use while loop now. There's a conditional, there's an incremental statement, and sorry, there is a condition over here that while loop will run till it is less than 101, which is 101. And if it is greater than 101, just exit from this while loop. Then we are incrementing this n, which is 1, to something to go about 2, 3, 4, and at the end 100. And since it gets to 100, the while loop satisfies this condition of the while loop, and we exit it. So yeah, but inside that while loop, we have still another conditions so that we can make some use of this while loop. Like we are creating some game which is fizz buzz, using some conditionals if and else if. It's nice. Let's move on. Simple code, I guess. It's a simple code, but a nice one. So we are now seeing the for loop. So there is a for and range. Let's see. Oh, All right. So there is the for and range. So the for in construct can be used to iterate through an iterator. So one of the easiest ways to create an iterator is to use the range notation, which is a to b, not equal to b, just to b. So this will go till sort of 100 only. But if we say equal to 101, then it will go to 101 too also. So yeah. So for in constructor can be used to iterate through an iterator. One of the easiest ways to create an iterator is to use the range notation, which is a to b or less than b actually. And this yields the value of one a, which is inclusive, and b, which is exclusive in step of one. What does that mean, inclusive, exclusive? Well, A is in the step and B is sort of one step ahead, which is then only we can run the loop. No, if we say run the loop from 1 to 1, then I don't think this will run much of a loop anything. It'll just run one condition, which is this. We are not printing anything because why not be printing anything? Why are not be printing anything? So it says n divisible by 15 to that phrase bus, so it should run, no? Yeah, it did run, but if we go over like 1 to 1, then there is no output because as we know, this is not a loop. If we increment it just by 1 enough, then this seems like a loop and we get a value of 2 because we can also do this 1 to 1, whereas 1 is now equal to 1. So now the count will, get from 0 to 1 because we are allowing it to be. Now this will also run to 1. All right. So it the first A has to be inclusive, which is inside the step, and B has to be exclusive, which is one step ahead or in step of 1. Now let's write the fizz bus using for loop instead of while. All right. So we'll do that instead of while. And the same internal conditionals, but over here we are not incrementing n because n is now running in a range. That's how we make it for the for loop. Very standard technique of for loop. I guess in C there was something like this, like for I, then we are creating that I from 0 or to 1. Then we are satisfying some condition like I is less than n or I is less than 5, I is less than whatever the range is. And then what we did was we incremented I in the whole for loop only. So it sort of looked like this, like for inside something like this, I is equals to let's say 0. Then we did something like I is less than 5. Then we said something, I guess we use semicolon instead of comma. I plus plus. This was the loop, and inside this, we wrote some conditionals. That's how we did it earlier days. Now this is Rust. So that's why we say it has many features like range. Now range exists in Python. We can run this for loop sort of looks like Pythonic because that also says in Python we have something like for I in range range of I. Now range is a Pythonic object in Python. So remember this, we are writing Python. This is Python. And then what we say, we use a colon and then we enter with a tab because that's what Python do. And we print the I. Can we do that over here also? Let's go to Python and we say for I in range of not of 5, and we first of all print I, and we don't need to increment it because I is going through the range of pi, which means 1, 2, 3 and all that. So let's print it. How will be able to print it? We can't use this This is wrong. How to do this? I'm stuck. I'm stuck. For I in range, which is 5, just run it. PRINT, print I. Was it print I? How's that? I've never used this shell, so I don't have any idea what I'm doing wrong over here. So let's move on. Let's only create no vim one dot y. That's what I can do. So let's say for I in range of 3, what shall we do? We should just print the I escape Python 1.py. Ah, only a spelling mistake, but we did not do any sort of spelling mistake over here. All right, so let's change it. RANGE. I don't know why this shell didn't work, but yeah, that's how we did in the old days of Python. I don't know why this shell was not working, because now the code inside that 1.py is exactly the same as this. Let's ask some, AI model. So let's go over there. Why is this not working in Python shell? Is it called Python shell? Was it, what is it called? I'm sending a reference for range, that's my example. So what is this? Yeah, it was indented. See, it was indented over here, but still didn't run. So what's the issue? It should be like this, all right? Press enter and then indent the next line with space or tab before typing print time. So let's do that, because I want to see what was going wrong with this shell. So let's say for I in range, which is a 3, I want to, it already has a tab, so I don't think I have to put some sort of tab to it. If I say this, now it should run, but it is not. How about now? Uh, this should now run, but it is not. What is it expecting from us? Let's do that. Spelling mistake. So good catch. The second line after this tells Python, I'm done with this block, execute it now. Once you press enter on that blank line, you should see. Oh, is that it? Ah, it was damn simple. I was making it complex. So it's like it will give us a new line, so that if you want to do something else, do it. Else, just press enter, and you're done. I'm liking this now. All right. Let's print hello. How many times? Let's say 3 times. I'm going to print HELLO, and whatever this I is, we'll say I, and we'll format it by F. Ah, not like this. And This enter 0, hello 1, hello 2. Since it was in range 3, so it started from 0, 2, but it has 3 elements. Notice that 2, 1, and 0. This range works sort of the same, but it has now 1 and 1, 0, 0. So how to write this range in sort of Pythonic function? So instead of, printing hello each time, let's make it short. And instead of printing it from 3, we'll print it from 1 and 2 to 100. Not 100, 101. Then I guess we'll see what I wanted to see. Something like this. Yes. Now this is the loop we were expecting from Python. And this is the loop that we are running over here. But this seems rather nice. This can also, like I was saying, I've seen this for loop multiple places. Like for bash scripting, if anyone has done that, bash scripting, we can also do this. Like this is my bash, all right? Like ECHO. And if I say shell, now this, okay, capital S, shell, it will say we are using bash. So we can now run some scripts for bash. So if I say, ls, now it prints the ls like one time. But if I say something like for I in range, not range, but for I in 1, 2, not 2, 2, I guess 10. I want to do what? I want to do ls, and then I do this. Syntax error, unexpected token ls. All right. So instead of doing ls, we'll do cat one dot one. Is it nice? It doesn't know cat. All right, we know that. How about we do something like I dot y? Why is this cat over there? Is there any print? print, print, print is also not known. Print I, printf, printf is there. So if it does not need printf, let's, instead of doing that, how about I? So printf is not known, so we create just echo. What I'm doing, I don't know. Let's ask some AI. I want to run batch script, script. Ah, so it has to be like do and then done. All right, do echo I and done. So let's copy this and paste it. So clear it. Now paste it. Yeah. How about if I say do what? Do something like ls. Yeah, now it does. What if I want to say, yeah, that's how we used, this loop. I remember that. I use this loop to create, multiple files, which is sort of in range of, let's say, 1 to how much? Let's say 5. We are only creating something like 5 files. What I want to do is I want to say do what? Uh, no. How to create file? Touch. 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 Uh, let's say do is the name. Inside that we are passing it. We are passing it. Dollar dollar ss dollar I. Then we are like this, and we'll say done. Let it do that. Let's see. Yeah, we have SS1, SS2, SS3, SS4, SS5. That's how we created, stuff. And let's say if I don't want to do this, I want to remove this. So instead of saying touch, I'll go like RM and then remove everything like that. It'll remove it. If I go like something like copy 1.py to everything like SSI and all that, it'll do that. So if we see any object SS1, let's take SS2, all right, it has the same damn thing that was in the Python file, which is 1.py. So we can use this scripting to, automate our bash something, if you want to check it. I created pdump yesterday. I remember that. I created something like dump. This is what I created. I just not directory, yes. Edge for him. So this is like not a binary, this is a script that is now there. And what it does, it copies everything, like mostly everything, and helps me to paste it. Let's say I run pdump over this pdump over this file. It says, yeah, it copied. What did it copy? It copied my tree and whatever the loop inside that was, something like this. So it has 1.py and the file content. It missed the file content, but all right. Then I created something like mdump, which is more interesting. Mdump. Oh, mdump is not found now. Whatever now. No. Then I create something like p3, I guess. P3. It's not there, then it must be there. P3. Yeah. This is P3. What it does, it hides all the unnecessary file that I don't want to see. So let's go over there and try printing it. So now inside this, there are many files like git ignore, git, and then the whatever, you know, if we run the normal tree, there are multiple files, stupid files like these. I don't want to see them in tree. It is inside target. Yeah, inside target. But if I run my own P tree, something like this will never be seen. See, like, and I can copy and paste this. Why I was doing all this? Because I was creating something interesting. We'll show it in rather next week or this week only, or near this next week or this week. So now we come back to our for range. So I think this is clear because we use this setup everywhere mostly, and in Rust also we are using this. We don't need to use colon. We don't need to use whatever this semicolon. We just say for range this to this, run these conditions in the for loop, and when any of these conditions satisfy, just print that, and then we exit the for loop over here, and then we exit the main loop, and we are getting fizz buzz like normal. All right, we are getting fizz buzz. So now alternatively we can use equal to, which will make it go up to 100, and yes, that's what it does. Like over here, how to shut this down? Yeah, Over here it was 101, but was not equal to 101. But over here we only want to go till 100, not over 100. So we are now like equal to 100. Don't go to 99 only. We want to go till 100. So yeah. So n will take the value of 1 to 100 in each iteration. That's what it does. Now for an iterator, now this is something new for us, I guess. Not that much. Not that much. We have used this. We have used range name and we used names like normal in Python. But this is Rust, so we have this iterators. We can just iter over the vector name 1 over 1, and we can use each of these names to match something like this. If it is Frank, then do this. If it is Bob or Paris or anything like that, just print the hello and name. So we read this theory and we'll move on to this code. So for an iterator, so construct is able to interact with iterator in several ways, as discussed in the section on the iterator trait. And by default, for loop will apply to into iter function, which was used to, something like into string. We used it something like into and then string, something like this. We have used it. Remember it. We have used this function somewhere. We call that. So where were we? So loop will apply the into iter function to the collection. Let's read it from here also. The for I construct enabled to the for in construct is able to interact with an iterator in several ways, as discussed in the section of the iterator. And by default, the for loop will apply the into iter function to the collection. However, this is not the only means of converting collection into iterators. Now there's into iter, then iter mute, which is mutable iter. All handles the conversions of collection into an iter in different ways by providing different view on the data within. So let's say there's a iter, then there is into iter, then there is iter mute. So we will see everything. So for just the iter, this borrows each element of the collection through each iteration, thus leaving the collection untouched and available to reuse after loop. So if we just go like name and there is a vector which is Bob, Frank and Ferris, outside that we are creating a for loop which is for name in names.iter, which is names dot, and then we are iterating over it using the method or function iter, and then we are trying to match the name. If it is something like Ferris over here, why we are using ampersand? Because we don't want to uh, sort of mutate it or sort of move this name from outside this vector name to this loop. We don't want to do this. So we are just taking the reference. If it is Ferris, then we just print that this is a Rustacean amongst us. So we know that Ferris is a Rustacean among us. And to try deleting this, the ampersand and match just the Ferris. Okay, we'll do that. We'll just remove this ampersand. And this is what? This is called wildcard. We know that. We know that because wildcard is used to compare all the other functions that we don't keep in mind, we don't want to know, but we want to match it to something. So we'll say hello and whatever the name is, and we say print the name. Then we are printing it in a debug mode because we have not applied the display for that, and then we are just printing the names. So let's do it. We have a name, and over here we are just printing the name, not names. So names is a vector, whereas name is just iterating over this vector. Let's run. And we see hello Bob and then hello Frank, and as soon as this Ferris comes, we have a match function for that. So we match this Ferris with this ampersand, which is by reference, and we say there is a Rustaceans among us, and then we are just printing the vector names. Now it told me to something like this, just to create some error or just to remove this Ferris from the names. either of the two. So I got directly just the error. So what does it say? It says that mismatched type. Why is that? So it says something like match name, and this expression has a type which is ampersand ampersand str, because of vector which is a pointer towards a pointer which is str, which is string. So Ferris, well, and this is expected a ampersand ampersand str, but found only ampersand str. Now notice that expected reference looks something like this, because Ferris in itself is a string which is ampersand str, and we are adding a pointer to that, so we should use a reference to it. And note that expected this and found the reference to ampersand static, which is not. So it says consider adding instead of recommendation, instead of doing this, how about adding this star? Let's do that. Right, it will dereference the pointer, so it will make it just a ampersand, just ampersand str, not ampersand ampersand str. So interesting. Let's leave it alone. Let's make it normal. It will also run. Now we learn about intuiter. So it is like we have again the Bob, Frank, and Ferris, and what we are doing is we are into iterating. So is this any different? Let's first of all run this code, and we'll see the theory in a minute or two. So it says comment me out. So we'll just comment it out for now. We'll run it. So we see hello Bob, hello Frank, and there is restrictions amongst us, but we can't just now print the name because I think it is busy somewhere over here, and now it has moved the pointer. So into it, this consumes the collection, so that on each iteration the exact data is provided, and once the collection has been consumed, it is no longer available for reuse, as it has been moved within loop. So yeah, see, it has this name and all these names have been moved inside this loop and has been consumed. So we can't just print the names after that, because this will give us an error that we want to see right now. So it gives us a long error. So we'll see borrow of moved value, which is names. So we are sort of borrowing moved value, which is names over here. All right, so it says that in the line 2 there was a names. Move occurs between names and has a type vector ampersand string, which does not implement the copy trait. Yeah, we know, because it is a string, so it does not implement the copy trait. So it moved out. Moved where? So from name in for names in the names dot intuiter, names moved due to this method call. So this method was called, which is intuiter. So names moved due to this. What is after that? We have print ln, which is names, and then this debug mode, we are trying to print the names which has already moved because of intuiter, and the value borrowed here after move becomes invalid. What does it says? So it says, now it tries to explain me that intuiter takes the ownership of the receiver, which is self, and which moves the name. So it's telling me if there is a function or method called intuiter which is taking the self, then it does something like this, which is returning the self and then intuiter. Note this error originates in the macro, which is create format args nl, which comes from the which comes from the expression of the macro, which is println in nightly build. Run with z macro backtrace for more information. We don't want to. So let's go here, and it says help, you can clone the value and consume it. All right, we can clone the name clone and then consume this using intuiter, and this will work fine because now it is cloning each bit. That's what we do with clone. All right, so it gave us a solution that just clone this value, so that now we can print clo clone, and now this name will be available because it has not moved, it has been cloned. So this name is now available because this name has been cloned before, being consumed by this into iter function. So now this is an interesting solution that we are cloning everything and then we are making it consume everything. And then now this name is now available for us. But let's not do it. Let's just keep it default. And let's not just print this name because we don't want this name anymore. Now this, I think this clone function becomes very important if we are trying to, take some data from some databases. We'll just import that data into, let's say, some vectors or something like that. And we have to then clone it so that we don't harm that database or the data in that database. Now there's another thing that is last, which is iter mute. So what it does, it has also something. So first of all, run this, then let's see what it does. So it has names hello, hello, hello. This is oh, so it so it mutates the whole Bob into like hello, and then Frank into hello, and Ferris. This is a station amongst us. So iter mute is like this mutable borrows each element of the collection and allowing for the collection to be modified in place. So it first of all borrows these collection of names and then it modifies those collection and puts the modified version in the place. So something like that. So there's a name vector which is Bob, Frank, and Paris. It matches C. This is taking this. This is taking the dereferencing, which is the name over here, and then what it tries to do is match the name, which is mutable Ferris, and then we are mutating it to there is a rustaceans amongst us, and see that this is not a statement, this is a return value. So therefore we are not using a semicolon, we are using a comma. All right, now there's a hello, and again this is a wildcard, but it is also returning for everything else except for Ferris, and this is a dereferenced name. So how about if we just don't dereference it? How about we just take it now? That's what we expected. So there is a difference which is mismatched type. That's what we expected. So what it says is there is a rustacean amongst. So type differs in mutability. So what it says is expected mutable reference, which is ampersand, mute ampersand, and whatever this is. So for this, we are mutating over here, but we can also mutate it over here. Something like this. This will also work, I guess. It doesn't. So I expected a string but found ampersand string because this is a string. So it has to also match, no? So it has to match to this. So it can't do this. But now what? Now this is a difference which is found the reference of ampersand static. All right. So let's just go back to how it was, which is dereferencing the name and then taking the Paris out of it, then mutating it to this is a station amongst us. All right. So in the above snippet, note that the type of match branch that is the key difference in the types of iteration. The difference in the type of course implies differing actions that are able to be performed. So it also says see the iterator. So let's see the iterator. What it says. Let's remove this fizz bus. All right. Now this is iterator. Where is this? It's in 16. So we'll have to wait. We'll be patient because this is also in Rust by examples. So we'll go through it. All right. So I think for loop is now finished. Let's move on. Now there's a match. A match is something else. See, it is a whole nested match. There's 30 minutes for us. So how about we see while let else, and if let tables in Rust 165. All right. What is this? If let. So it's a long way across. So we'll try finishing it up. So for match, now we see that this is a match, and we are seeing that Rust provides pattern matching via match keyword, which can be used like C switch. So there is a switch in C. So match is similar to that. We know that obviously. The first matching arm is evaluated and all possible values must be covered. Yeah. So there's a number which is 13. Try different value for numbers. We'll do that. Then it says, tell me about number. Then it is trying to match the number. If it is 1, it prints 1. If it is 2 to 11, no, it is 2, 3, 5, 7, 11. Then it says it is prime. So every prime number, it says prime. Try adding 13 to the list. Uh, we can, but 13 is also used over here, because then there will be conflict, sort of, or if there is not conflict, then it will just print that this is prime and not this. And from 13 to 19, there is a print statement which says it is a team. And for wildcard, which is everything else, like 4 and everything like that, we'll say aim that special. All right. So commenting out of this catch all arm. We should not, because then this is not exhaustive match. This is now inexhaustive match. So we must use this wildcard. After that, we have a let boolean is true, and binary search which matches the boolean. Let's say false is 0 and true is 1. So we match the boolean, and since it is true, we get 1. All right. And then we are printing the boolean and the binary, which is like this. Binary is getting the value from this. It is a returning value. It is not printing it. So let's run it. It is an interesting program. So tell me about 13. So it is a teen, which is over here. But it says the next thing to do is, how about adding the 13 over here also? Will it give it some? Ah, so it just matches the 13 over here and returns from here. It does not even go to this. All right. So I think that's what we expected. It'll just give us, or we expected that this is Rust. It might even give us some errors, but it didn't. And now we are not making this exhaustive. We'll make it non-exhaustive or inexhaustive. Let's try running it. We should see some errors. It says pattern and all that. It says non-exhaustive. So it is not an inexhaustive, it is non-exhaustive. So non-exhaustive is the word over here. So we see that non-exhaustive pattern, which is whatever. We are not exhausting all the patterns that exists. That's why we are getting it. How about we say number? How about we run a loop for number, and then inside that loop we match the number. We can do that, but now we'll have to, have the patience to do that. But how about we do it? We do it for loop in range of 1 to, let's say, 20. Where is 20? Not 30, 20. 20 only. And this, we are giving it over here. All right. When we run it, is there any errors? There is, which is expected pattern. For what in numbers? So for I in numbers. 1 to this. Then we have to match, I instead of num. So instead we'll say num. We'll run it. It will give us an error. Then we'll change this number to num. which is exactly what we wanted to do. Let's see it. What's there? Add this statement away. We added a semicolon. Let's go. Not found in scope. It's num now. It's not number, it's num. So it tells us about one, which is one. Tells us about two. Also, one is one. Otherwise, I thought it'll say ain't special or something like that. But over here it's two, so this is prime. Four, this is prime. Three, this is prime, and four ain't special. Oh my god. Now for 5, this is prime. For 6, ain't special. 7, 8, 9, 10, 11, 12, 19, a teen. And as for 13, we are just getting this is a prime. But if we remove it from here, which will just give us a teen, it will give error. Why? Because we are using this pipe. We should remove this pipe. Now let's go on. Yeah, so we see 13, which is a teen, 14 teen, 15 teen, all that teen. So interesting. First of all, congrats to ourselves because we know how to use now for loop and how to assign the value of whatever this for loop returns to this number. If we try to print the number, what will it give us? So let's try doing that. Go to end, go to home, copy it, come up over here, take a next line, print it instead of num, we say number. Let's do this. We get an error. So it says required by the format. So we don't have a oh. So I guess we'll just get a unit type. But still, you want to see this, so we will see this, even if it's a unit type, which is not interesting. But let's see this. Go. It'll give us a first of all, yeah. Tell me about this unit type. Then the boolean is running, which is true, which is one. So yeah, the number is what? Number is unit type. But if I wanted to break at 20, then I would get something like 20. Where we break 20 directly. I think this will not work. I'm hoping it works, but it doesn't. Can only break with a value inside loop or breakable block. Oh, so we can't break in for loop. It only works for loop. As for help, break is without a value inside for loop. So we can just break this value without passing any value to it. Which is that it runs for the first match and then breaks the loop. Then it tells us about the unit type, which is a number now. Then it goes for the boolean. Interesting. So I guess we shall move on from this match to subtypes of match, which is destructuring tuples, destructuring array and slice, destructuring enums, and destructuring pointers and destructuring structures. Tuples, array slice, enums, pointers self, pointer ref, and then structs. And then there is guard and binding. Oh ho, oh ho. So first destructuring, then guards, then binding. So this is a long thing. A match block can destructure item in a wide variety of ways. Let's see how many varieties. So tuples can be destructured in a match as follows. So let's say there is a triple. What the hell? But this is a tuple. All right. Try different values for triple. Then we are trying to print, tell me about, triple, which will print this triple. And match can be used to destructure a triple, which is we are matching the triple. And we say if it's 0, y, and z, then it says first is 0 and y is whatever this y is, and z is whatever this z is. All right. Then we say 1 and whatever, which is like first is 1, which is not, and the rest doesn't matter. The first is whatever it is, and the last is 2, rest doesn't matter. 3 and 4. So I think this will only run this first case. As for it doesn't matter what they are, will not be able to run. Let's see. So we see first is 0 and y is -2, z is 3. So this runs. Now if we just go on like add a 1 to this tuple, and this will print us this second one. Oh, it didn't. Why is it? Why is it? Integer. Destructure the second and third element, which is y and z. So this doesn't work, which is 0, y, all that. So let's comment it out directly. So it was thinking like there was only, there was 0, y, and z, but we proved it wrong. We are like, whatever the front is. But now we'll say there's a 1 also. And it should run properly. Yeah, it did run. And it says first is 0, y is, because this condition now satisfied. But we don't want it to satisfy. So now we run this. But the second element is was -2 and the third was 3, and now it has nothing, so it shouldn't be even printing right now. So let's go, just try different cases. So we get first is 1 and the rest doesn't matter. How about we make the rest as just my 2 instead of this? What happens then? It returns the first one only. So how about we just remove this first one? Let's go. It says last is 2 and rest doesn't matter. Let's go start from 3 and go till 4. So let's go from 3 and at the end we go up to 4. And the in between doesn't matter. So it will say something like this. First is 3 and last is 4. Rest doesn't matter. As for anything else, like if it doesn't matches any of these cases, like the earliest one, but we remove this. Now it goes like it doesn't matter what they are. Yeah. All right. So this means don't bind a value to a variable. This is a wildcard. And this, which is 2 dots, can be used to ignore the rest of the tuple that we don't want to see. Tuples is all right. We'll go for array and slices. So there is an array of 3 and I32 is the type. So if we want to write it, we'll write it something like this. 3. No, I32 is the type and it is of length 3. Something like this. Expected a semicolon or this. So I was confused if it was semicolon or just a comma. Let's go. Yeah, so it works. We are just defining that arrays of type I32. So all these 1, -2, and 6 are of type I32. We can't just go on and say U32 because it takes only unsigned integer, which is not here, which is because of -2. It's here, gives us a error, cannot apply unary operator like this, and goes on to explain why. All right. So now we have to focus on match. So try changing the value in the array or make it a slice later. Let's go on match. What it says is 0, second, and third. So 0, second, and third, which is by index. It says print array 0, print array 1, and second and third, whatever this is. Array 1 is second, and array 2 is third. Let's go. Will it print this or will it print this one? I guess it will print this one because this matches our array. So it will print array 0 is 1, array 2 is whatever, and array 1 will say was ignored. Like in between, this -2 was ignored, and array 2 was the third, so it was printed. Yeah, it says array 1 was ignored. We know you. If we just replace it by 0, and it will give us the first, which is this. It will print everything. Yeah, array 0, which is 0, array 1, which is -2, array 2, which is 6. Exactly what we expected it. And instead of 0, if we say like -1, we have the third condition over here. Third match, which is this. If it matches something like this, then it will print the second one and the first one, I guess. First one is -1 and the second one is whatever it is. And the rest doesn't matter. Yeah, see? So the code below would not compile. Why? Because we are not doing anything. But let's see the error. Will we be able to see that error? I don't think, because this might stop us from that. But since this is an error and we'll see that in compile time, so we should be able to see this error. So it looks like this, that unexpected token, which is this. If you are trying to use this, it is trying to help us, but rather it is not helping us. So yeah, it has to at least have some value to it. Otherwise, what are we doing it? What are we doing with this? Nothing. If we just said something like print ln and just something like macro, first make it macro, inside that we say something like hi. Still error. Why? It says line number 26. Where is 26? We didn't use the semicolon. Sorry. Now, the print. My God. P-R-I-N-T. Now everything is right. Let's print it. Oh my God. What it says? Match arm body without a braces. What does that mean? So it says while passing the match arm sticks. So replace this with replace. Did we add a comma? No. But that's what it's telling me, because we are matching it. We are not returning anything. So we are returning it. All right. So we are matching with returning it. We should use a comma. All right. Now what? Expected a third element. All right. So we expected a third element too. So let's just keep it like the above. Interesting. So after making us solve all this damn thing, is just going to print the above one because it looks the same. I mean, it is the same. All right. Let's say if this was 3, not anything else. Let's say this was 6. Now this should print high, but just print the high. It is not. Because this is satisfying it, because it takes for anything. But we want to say not 6. Will this work? I will be surprised if this works. Yeah, I am not surprised. I am not surprised at all. So this doesn't work. Just say anything except 6. Will this work? All right. We are seeing something that we don't understand. So says add comma, do this, do that. It's freaking out right now. So let's say not equal to 6 and anything else. Expected a pattern. Everything else except nah. Anything else? Pipe, just or nah. While passing this or pattern is starting here. Uh-huh. Let's try running it. You want to see it happen. Let's go with this. Nah. So it's freaking out. All right. So we can't do this. So just remove it. But we want to keep it sane so that it has to have some third element. Otherwise, it will throw an error. Expected 3 elements. So we'll say hard coded 5. Now if it is 6, we see high. If it is 5, we see dash and dash. But what if it is none? Like it is, let's say, -6. Then what? What will we see? Will we see something interesting or just error? Oh no. What did we see? Middle is this array. Where is this? Ah, we see this. So first is this, middle is that, and last is this. All right. So instead of seeing these two, which is not the case, so we jump at the last, we see this. It is just interesting because first is not declared, middle is not declared, last is not declared. And what is this at the rate doing over here? It says middle at the rate or whatever. So combines these pattern, we can, for example, bind the first and last value and store the rest of them in a single array. Oh, okay. I guess I'm getting some hints over here. If we just use last, then we are seeing this. But if we use something like at the rate, what is it? Why is there at the rate? So I want to see this. It's an expected binding pattern. So if we say something like this, so it does that. Now, if we say not 6, I think since it's 12 o'clock, I will just clock out or end the stream after compiling this, but it doesn't compile. So I think we should move on. We should move on. All right. So I think this is it. Array and slices over here. So we just were able to complete this. After that, we have enums left, pointers and refs left, structs, guards, binding. So this is like a long topic. We'll do that. We'll do that sooner, like yesterday or something like that. So for today, I think I will end this stream. Bye bye. See you later. End it here. Damn it.